Hello everyone. Myself Dr. Ashish Arora, Assistant Professor, ABES Engineering College, Ghaziabad. Today our topic of discussion is triple integral. Let fxyz be a continuous and single valued function of f of x, y and z. Let V be the bounded volume by surface S. Divide volume V into subregions, say del V1, del V2 up to del Vn. Then triple integral of function fxyz is defined as triple integration over V fxyz dv equal to triple integration over V fxyz dx dy dz equal to limit n tends to infinity summation I starts from 1 to n f xi comma yi comma zi into del vi, where del x, del v, del z be the volume of subspace and xi comma yi comma zi be any point in the subspace. If limit n tends to infinity, summation starts from 1 to n f xi yi zi into del vi exists, then we say that triple integration over v fxyz dx dy dz exists. The triple integral over v of function fxyz dx dy dz represent the mass of volume v if fxyz represents density for function v. Suppose if we take fxyz equal to xyz square, or we can say that uh, uh, the functional value of fxyz is not constant, this is the variable value, then this will be treated as density, and we know that the volume and density equal to mass. So the triple integral over v fxyz dx dy dz represents the mass of volume v if fxyz is density function for v. If the value of function fxyz equal to 1 or unity, then triple integration over v dx dy dz represents only volume. Now we'll evaluate triple integral. The triple integral over v of function fxyz dx dy dz over a three-dimensional region v is evaluated by three integrals. Suppose in first integral we take limit z depends on x and y depends on x, and x is constant. Then we get triple integration over v of function fxyz dx dy dz equal to, here we integrate first with respect to z, then with respect to y, and in the last with respect to x. So the limits of z will depend on x and y, limit of y will depend on x, and the limit of x will be constants. This integral can also be evaluated as suppose if we want to integrate first with respect to x, then with respect to y, and in the last with respect to z, then we will take limit, then we take the limits of x in terms of y and z, and limits of y in terms of z, and limits of z as constant. Or if we want to evaluate the integral with respect to y first, then we will take y, the limits of y in terms of x and z, and second, if we want to integrate with respect to x, and then we'll take the limits of x depends on z, and in the last we will take the limits of z as constant. If x1, x2, y1, y2, z1, z2 are not variable and all the limits are constant, then the order of integration is immaterial, provided the limits are changed accordingly. This will depend on the demand of question. If our question is given like function is given to us, and if we want to integrate first with respect to x, then with respect to y, and in the last with respect to z, then the limits of x will be given first, then second with respect to the limits of y will be given on second place, and the limits of z will be given on final position. Okay. Similarly, if the question is given in the form triple integration of function fxyz dy dz dx, then we will integrate with respect to y first, then with respect to z, and in the last with respect to x. And if the question is given like a function fxyz and dz dy dx, then first we will integrate with respect to z, then with respect to y, and in the end with respect to x. Now we'll take and then we'll take a question. The question is that evaluate triple integral. The given function is, this is the function f x y z, which is given exponential e to the power x plus y plus z, and the limits are given 0 to x plus y, second 0 to x, and in the last 0 to a. So first we will integrate this function fxy with respect to z, and we know that if we want to integrate with respect to z, we will treat x and y as constant. Then we will get the 0 to a, 0 to x. First we will integrate with respect to z, then we can take e to the power x plus y outside, and we will integrate e to the power z, and we know that integration of e to the power z is e to the power z. Now we'll put the limit in place of z. Then what we'll get? 0 to a, 0 to x, e to the power x plus y, e to the power x plus y, and for the lower limit e to the power 0, which will be 1 dy dx. Now we will multiply e to the power x plus y with e to the power x plus y and e to the power x plus y by 1. Then what will we get? Limit from 0 to a, 0 to x, e to the power 2x plus 2y minus e to the power x plus y dy dx. Now we will integrate with respect to y, treating x as constant. So we know that integration of e to the power 2y is e to the power 2y by 2, and the limit is 0 to x. And we know that integration of e to the power y is e to the power y, limit is 0 to x dx. Now we will put the limits of y, e to the power 2x, e to the power 2x by 2 minus 1 by 2 minus e to the power x, e to the power x minus 1 dx. 0 to a, 1 by 4 e to the power 4x minus 1 by 2 e to the power 2x minus e to the power 2x plus e to the power x. Now we will integrate with respect to x. What will we get? 1 by 4 e to the power 4x by 4 minus 1 by 4 sorry, this is 2, not 4, this is 2. 1 by 2 e to the power 4x by 4 minus e to the power 2 e to the power 2x by 2 minus e to the power 2x by 2 plus e to the power x, and we substitute the limit of x from 0 to a. What will we get? E to the power 4a by 8 minus e to the power 2a by 4 minus e to the power 2a by 2 plus e to the power a. This is for upper limit minus 1 by 8, and we got e to power 0 equal to 1 minus 1 by 4 minus 1 by 2 plus 1. Now we simplify it, and what will we get? E to the power 4a by 8 minus, after simplifying, 3 by 4 e to the power 2a by 2 plus e to the power a. And after simplifying all these, we will get minus 3 by 8. So the value of this integral is, sorry, this is here, e to the power 4a by 8. So the value of this integral is e to the power 4a by 8 minus 3 by 8 e to the power 2a plus e to the power a minus 3 by 8. So this is the value of required integral. Here are the references: B.V. Ramanna, B.S. Grewal, R.K. Jain, and S.R.K. Iyengar. Thank you.